Alrighty, so before, the last thing we talked about was just kind of an introduction into the trig identities. And today we're going to simplify them, just still using the ones we know. We'll get to some of the other ones as we go through. So when we want to simplify a trigonometric expression means we're going to rewrite it as a numerical expression or in terms of a single trigonometric function. Okay? So it's kind of like simplifying a fraction or something like that. We're just going to rewrite it. It's going to have the same value. It's an expression, not an equation, so we're not solving anything. We have some strategies to get us started, and which strategy you use depends on the question, and which way is easiest is whatever makes the most sense to you. There's different ways to work through a lot of these, and that's fine. I'm going to show you a few different things. On some of them, I'm going to do the way I feel like y'all as a whole would most likely go, which road you'd most likely go down. And on some of them, I'm going to do it where I think that you wouldn't do, just so you know what your options are. So here are some things to think about when we go through these. You can rewrite them using the reciprocal and quotient identities, which we already knew before we started this. We can look for the Pythagorean identities. Anytime there's a squared, you want to think, oh, let me go look at the Pythagorean. Maybe there's something I can do with that. We can combine fractions using a common denominator, and we can break fractions apart. Now, this one is the one where I feel like most of the time that's not going to be your first thought, because we put fractions together a lot, but you're not in a lot of situations where you break them apart. But you need that skill and to be able to recognize that moving forward for sure. And then, of course, use factoring. So I'm going to talk you through kind of the thought process of some of these, but this is one of those things where we just need to do a bunch of them together so you can see a bunch of different things. It'll get easier as we go through today. It'll be a little bit more obvious for you, and when you're working on your own, it's just going to take some practice as well. Once you get the hang of it, I think a lot of you will actually like them because they're like little puzzles, okay, and it's not really that big a deal. The work that we're doing is basic arithmetic and basic algebra. So you kind of need to remind yourself of that when you're trying to make it too hard, because we're really good at trying to make things too hard. I think kind of all of us, it's one of our strengths, if you want to call it that. So let's look at number one. I want to simplify this. So I kind of want to think algebraically first. Like I have two terms. Do I have a GCF? No, I don't. So there's nothing I can factor out. There's nothing I can combine at this point or anything. So one of the go-to things when you kind of feel like nothing really jumps out at you is changing everything to sine and cosine. But that's definitely not how you want to try and approach everything, because sometimes that makes it way too hard. But we're just going to go ahead and do that with this one. So secant, I'm going to use the reciprocal. The reciprocal is cosine. So this gives me 1 over cosine. Minus, I'm going to leave sine alone. And then tangent, I'm going to change into, what's tangent? What over what? Do we remember? Do we forget everything? Sine over cosine, because we've known that for a long time, right? Sine over cosine. Yes, I've just substituted. And as I go through this, I'm only really changing one thing at a time, because even if you see more than one thing, sometimes changing more than one thing at a time, you miss something you could have canceled out or whatever. So it's good to just do it a little bit at a time. So I can see in this second term that once I multiply those, that's all one fraction. I have two fractions, and I have a common denominator already, so that's great. So I know my common denominator is cosine theta. Then the numerator is going to be 1 minus, well, sine times sine is sine squared theta. Everybody with me so far? Okay, if I lose you somewhere, you're not sure where something came from or whatever, please ask me right then. Those of you that never ask me anything, please ask me right then, like where the heck did that come from or why did you do that, instead of 3 steps later, okay? Don't be afraid to speak up. You can be the first one, I guess. All right, so now that when I looked at this, I have the squared, so I'm thinking, all right, I'm going to go look at my Pythagorean identities. So I go and I look at my reference chart. And the Pythagorean identity that has a squared in it, the sine squared, is sine squared theta plus cosine squared theta equals 1. Now, when you're on your notes, maybe you want to write all this stuff out to the side that I'm doing. I'm definitely doing it so you can follow my thought process. Once you get the hang of this a little bit better, you don't always have to write it down off to the side. You can just kind of look at it and think through it. Probably not a bad idea to have it written down in your notes, so if you go back, you know where stuff came from, since it's still kind of fresh. So I have some options here. I could take this and solve for sine squared and then substitute it in. Or I could take this and manipulate it to get 1 minus sine squared. Well, to get that, all I have to do is subtract sine squared over here. So that means that cosine squared theta equals 1 minus sine squared theta. Right? Both of those things would have to be true if the first one's true. So now I can substitute. I got 1 minus sine squared. Instead of that, I can substitute the whole numerator with cosine squared. So this gives me cosine squared theta over cosine theta. Now, when you first started doing square roots and radicals, some of you, probably a lot of you, because it's a very common thing, tried to make up math and do weird things because they were square roots, so you felt like it had to be weird or different or hard. But if you just think of about them as variables, then it's not that big of a deal. Same thing here. Just because we've got trig stuff in here and it looks a whole lot worse than a lot of what you've done, doesn't mean that it's any more difficult. So in any level of math and anything you're doing, if you're unsure about what to do, take it back to something you can connect it with that you know for sure you get. So instead of thinking in terms of cosines, if I think in terms of variables, like what if this was x squared over x? Would you know exactly what to do? You could simplify that hopefully and get it right. So you're doing the same thing here. If this, whatever you get here, what would I get from this? What's going to happen? This cancels out with one of those, and I'm just left with cosine theta. Just like I'd be left with x right there. Okay, we good? What questions do you have? All right. Look at number 2. So again, I don't have a GCF or anything, so I'm not going to factor out. I don't have anything squared. I don't have any fractions. So I think I'm going to start using some reciprocal stuff. I already have this sine and cosine, so I'm just going to fix this tangent. So this is equal to sine A plus cosine A times, what's tangent? It is sine over cosine. And notice all along I have equals, and then I rewrite everything. Equals, because that's part of, when they're grading your AP test, you better have those, you know, and everything's there. I didn't just have a little piece of this and write random things. Like, it's logical steps that you could actually read through. So here I can cancel. This cosine, or that cosine cancels with this one. So this leaves me with sine A plus sine A. And again, I'm not going to do weird things just because it's trig. If I have sine A plus sine A, that's going to give me 2 sine A. Every answer I get should be one term, no fractions. And sometimes it's a number, sometimes it's a trig expression. It just depends on what happens. Okay, we all good so far? All right, so let's look at number 3. And we want to think about this algebraically. So I want you to look at that and just think the algebra part of it, not the trig part of it. What kind of situation is there that we could factor? What's that called? Somebody speak to me, because I know you know this. What if this was x squared minus y squared? What's that called? It's really easy to factor. Thank you. It's a difference of squares. So this is a difference of squares also. You need to be able to recognize that, whether it's in trig or variables or whatever. So if it's a difference of squares, that on this particular one, that's actually not going to help me. But here's what you want to do is you want to think through it. What if I did do that? Because maybe it would on another one. If I did factor that, again, think in my head at least what it would do. It would break up the cotangent and cosecant. But then I don't know that that does anything for me. I'd have a bunch of fractions when I did my quotients. So even though I could do that, and we still are going to have to do that eventually on some of these, I don't know that I want to do that here. But always try and recognize it first. So I could work this one. Really, there's like 4 quick and easy ways to work through this. So I think I'm just going to pick one of them. where again, I feel like most of you would probably go down that road. This does have the squareds in it. I could use the Pythagorean, but that for some reason is not always what's in the forefront of everybody's mind. So instead, we're going to go ahead and work with this one as as reciprocals and quotients. So, and it doesn't matter which one you do, okay? You're going to get the same answer if you do it right. It's whatever makes the most sense to you when you start. So if tangent is sine over cosine, then cotangent is cosine over sine. So this is going to be cosine squared over sine squared minus, and then cosecant squared is going to be 1 over sine squared. So now I have two fractions. I already have a common denominator. So I'm going to put that together, and it's going to give me cosine squared u minus 1 over sine squared u. Okay, I have squareds. Now, I have squared in the numerator and the denominator. Most of the time, the numerator is what you want to work with if you can choose between the two. Especially if your denominator is already one term. If your denominator is more than one term, you might want to try and work on that because it's yuckier when you have a denominator with more than one term. But I'm going to leave my denominator alone right now, worry about my numerator. So I go and I look at my reference chart, and the Pythagorean identity that has cosine in it looks like this. Sine squared u plus cosine squared u equals 1. Well, I want that to be cosine squared minus 1. And it's not going to, the answer is not sine squared. And again, you can actually write it out or you can think about it in your head. Just make sure you can actually think through things correctly in your head. It doesn't get lost in there. Yeah, I would need to subtract the 1, so I'd get cosine squared u minus 1. What would I have to do with this sine squared? It has to go to the other side, right? So that would have to be minus sine squared u. Like these two are the same thing. Basically, I subtracted 1 from both sides, and I subtracted sine squared from both sides. They have the same value. So I can substitute. Instead of cosine squared u minus 1, that's going to give me negative sine squared u. And then what does that become? What do you think? Am I going to have a trig left in the answer? No. Just going to cancel out and give me negative 1. Okay. What questions do you have? Had we factored it and then gone from there, again, there's nothing wrong with that. We would have just had some extra steps. And you're not always going to recognize that at first because you may only see one way. Go with it. Sometimes going with what you see is better than sitting there for 5 minutes trying to figure out something else. You should try at least think through it a little bit before you start, that instead of just jumping in and doing random things, because if you don't have a purpose for what you're doing, you could just be going in circles. All right, so let's look at number 4. Here are my options for number 4. Me personally, when I look at that, the first thing I want to do is distribute. Okay, but I'm going to think about what's going to happen if I actually distribute. If I do, which again is not wrong, and I could still work through it that way, I don't see that that necessarily benefits me any because I don't get any kind of squared stuff. I just get a more complicated numerator. So I don't know that I want to do that. I could change tangent and cotangent into sine and cosine, which again, absolutely nothing wrong with that. But then I know I'd have a fraction and a fraction. You can't always avoid that, but I think most of you, if you can avoid it, you're going to try and avoid it. And that's fine. I mean, I would too if I don't have to make it harder if I don't want to. So I'm going to change this to something that most of you probably wouldn't necessarily think to do at this time. This is the same thing as the sine of x over cosine x times tangent x plus cotangent x. So look at that. Make sure you understand how it's the same thing. Think about going backwards. If I put what's in parentheses over 1 and multiplied, I'd get what I started with. Okay? So that's not really the splitting of the fraction that it was, or breaking fraction. That's not really what this was talking about, but it works. Okay? Any questions about why that's legal? Do we understand why I don't still have a cosine underneath the parentheses? Okay. All right, so now that I do that, and again, I don't have to have this stuff memorized, but the more comfortable with it you are, the better off you are, because hopefully by now, when you see sine over cosine, that should make you think what? Somebody say it. What's sine over cosine? Tangent, thank you. It's tangent. So I'm going to change this to tangent. And if I have to look at the chart every time to figure that out, it's going to make things a little bit more complicated, where I feel like we've done that so much, we probably should just know it. And then times tangent x plus cotangent x. Now when I look at that, I think now if I distribute, I think that might actually be helpful to me. Which, again, is why I could have distributed at the very top, and eventually I would have gotten there. But so if I distribute this, I get tangent squared x plus, and then I'm going to multiply tangent times cotangent. Those are reciprocals of each other. And if you multiply something by its reciprocal, what do you get? Every time. This is the definition of a reciprocal. You multiply them two together and you get 1. Right? So since tangent and cotangents are reciprocals of each other, when you multiply them together, you get 1. So now I think, oh, look, I got a squared. So I go and I look at my reference chart. And I find under the Pythagorean identities, because they're all at the top right there, there's only 3 of them, that tangent squared x plus 1, I have something exactly there that I could substitute in, and that gives me secant squared x. Are we good? What questions do we have? By the time we get to the back, when we did number 7 last period, somebody was like, that's the one that made the most sense, which is actually more complicated than some of these. But I think it's just because we had done so many, it's going to start to feel a little bit better, I promise. All right, so let's look at number 5. I have 2 terms. One of them is a fraction. I have a Pythagorean, but I don't know that I want to substitute just yet. Usually, if you have a fraction and it's more than one term, your first goal is to put the fractions together. It's usually the most helpful thing to do. So we're going to get a common denominator. The common denominator for these 2 is going to be cosecant. Okay? So if my common denominator is cosecant, then that first term has to be multiplied by cosecant over cosecant, which means this becomes cosecant squared. This was already in there, so then that's just minus cotangent squared. Okay? Basic fraction knowledge, super important. All right, so now that we're here, everybody okay with how we got that? So now I've got some squared stuff. So I'm going to go look at my reference chart. I don't have anything that looks exactly like that, but I have cotangent squared plus 1 equals cosecant squared. If I want to substitute something for cosecant squared minus cotangent squared, then that would mean I would just subtract cotangent over there and be left with 1. So I can substitute a 1 right there and have 1 over cosecant theta. Then the reciprocal of cosecant is sine. What questions do you have? It's a different way to, well, there's different ways to do a lot of these, but at this step I could have done something different, which is kind of what we're going to do on number 6, is that we can split the fraction. And that's the one where sometimes I don't think it's always what's real super obvious to you, because we don't spend a lot of time splitting them. We spend most of the time trying to put them together. So if I have this, I can split it into 2 fractions and it would look like this. Cosecant beta over cosecant beta minus sine beta over cosecant beta. Make sure you understand and you believe me when I say they're the same thing. Because if I combined the fractions back together, I'd get what I had started with. So now that I've split them, that first one's going to reduce, and that's going to give me 1. Then I have the sine over cosecant, so I think I want to go ahead and make the cosecant into its reciprocal, so I would get minus sine beta in the numerator, and then the denominator is going to become a fraction because cosecant is 1 over sine beta. I caution you against trying to skip steps because first of all, then you're not showing your work. And second of all, sometimes it seems real obvious to you what's going to happen, but you're wrong because you're just thinking about it backwards. So I'm dividing, but that's the same as multiplying by the reciprocal. So this is 1 minus sine beta times the reciprocal of this, which would be sine beta over 1. So that gives me 1 minus sine squared beta. So I've simplified, I've got it squared. So I'm going to go and I'm going to look at my reference chart. I don't have anything that looks exactly like that, but I should be able to look at the one that looks kind of like it and understand what I could substitute in, and this will become cosine squared beta. What questions do you have? Anything? Okay. Do you feel like it's getting a little bit better? Okay, and that's why we're doing so many, because it's just, you got to kind of get in the groove of it and see how to look at things a little bit differently. Alrighty, so number 7. I have 2 fractions. My first goal, no matter, unless I could just cancel something out right here, which most likely is not going to happen, I want to just go ahead and get a common denominator and put them together. So the easiest common denominator is just going to multiply the 2 together. So that'll be sine u times cosine u. Wait, what? I could make this into a tangent, and then I could do tangent times sine and get a common denominator, but I'd still end up having to get a common denominator and putting fractions together. So yes, and if you did it that way, you're going to end up with the same answer in the end. You might have less steps, you might have more steps, it just depends. But yes, there's definitely more than one way to do almost all of these. But unfortunately, I don't think I can just completely avoid the fraction thing. All right, so when I do this, this first fraction is going to have to be multiplied by cosine over cosine. So this is going to give me secant u times cosine u. Minus, and then this one has to be multiplied by sine over sine. So that's going to give me sine u times sine u. All right, so this first term here, or let me just go ahead and rewrite my denominator. This is sine u, cosine u. So this first term, secant times cosine, those are reciprocals of each other. So when I multiply the 2 together, what do I get? 1. So these multiplied together give me 1. I don't even have to make it into a fraction or anything. You just know they're reciprocals. You're going to get 1. And then sine times sine is sine squared. Okay, then now can I cancel some signs out right here? No, because I have more than one term, right? So I can't cancel anything out. But I got a sine squared, so I go back and look, and if I hadn't figured this out by now, if I do 1 minus sine squared, that's the same as cosine squared. So you get cosine squared over sine u cosine u. Now I can simplify some stuff because I can cancel this cosine with one of those. So that leaves me with cosine u over sine u. And then cosine over sine is cotangent. What questions do you have? We good? Okay. All right, so when we look at number 8, do you think I could split this fraction and make it tangent over secant minus tangent over cosine? Does that seem like a logical fraction thing to do? The answer to that is no. You don't get to split a denominator, you get to split a numerator. So I can't split that fraction. And it would be way better fraction-wise if I actually had one term in the denominator instead of 2. And so although I can work with the numerator and denominator at the same time, it's better just to work with one thing at a time. So I would like to fix my denominator first. I'm just going to leave my numerator alone for a while. So when I look just at the denominator, nothing I can factor out, I think I'm going to need to use my reciprocals and quotients. So that means I'm going to leave the numerator. It's just tangent alpha. He's just going to hang out with us while we work on the denominator. Secant is the reciprocal of cosine. So this gives me 1 over cosine alpha minus cosine alpha. So it seems that I have made my denominator worse, but it's got to get worse before it gets better sometimes. So still just working with the denominator. So I'm just going to rewrite my numerator, tangent of alpha. So what I need, since I have two terms in the denominator and one of them is a fraction, is I need my denominator to have a common denominator. Because since I have a fraction and a fraction. So the common denominator of the denominator is going to be cosine alpha. That means my first term, since that was already a fraction, is just 1. This has to be multiplied by cosine over cosine, so it's 1 minus cosine squared alpha. Everybody with me so far? Okay, so still leaving my numerator alone, tangent of alpha. I've got this squared here. When I look at my reference chart, 1 minus cosine squared is the same as sine squared. So this becomes sine squared alpha over cosine alpha. So now at least my denominator is one term. It's a fraction, but that's okay. Hopefully by now you're used to things looking ugly and just knowing that just because it's ugly and it looks more difficult doesn't necessarily mean that it is. All right, so now if I look at the denominator, and by the way, one of the most common mistakes that's going to be frustrating for you if you make it is when you're working through this, like here, even though you know that this was sine squared, like just putting sine by accident because you left off the squared, then obviously I couldn't have substituted this, so you're going to be stuck or start to try and make things up. So just be very careful with the squareds. And if you get to a situation like this, like, oh, maybe I left the squared off here, but I didn't. It's not supposed to be squared over squared. So always go back and double check yourself so you're not just, then you get in a loop because you're going down and making things harder. So sine over cosine, I know is tangent, but that's sine squared over cosine. So it's tangenty, but it's not tangent. Like I can't make it, I can make it into tangent times sine, but I don't know that that would necessarily help me, and some of you wouldn't understand how to rewrite that correctly with confidence anyway. So it's even since I at least know it's kind of tangenty, instead of trying to make this into tangent, I'm going to make this into sine over cosine. So now I'm going to work with my numerator and make it sine alpha over cosine alpha. And then the denominator is still sine squared over cosine, which makes it look even worse. But honestly, if you're going to have a fraction and a fraction, y'all are going to make less mistakes if the numerator and the denominator are both fractions, because it just seems to make more sense. So now I'm going to multiply by the reciprocal. So my numerator is sine alpha over cosine alpha. Multiply that by the reciprocal of this, so that's cosine alpha over sine squared alpha. Those cancel out. This sine cancels with one of those. It's going to give me 1 over sine alpha. And then the reciprocal of sine is cosecant alpha. If you would know exactly what to do here, which some of you would, some people wouldn't, so that's why I don't do it that way. But some people don't see to split the fraction away. You want to be careful with just knocking stuff out, though, because that would work here, but sometimes you think it's going to work and you have your fractions flipped, so just make sure you're really thinking through it right. Yes, and also be careful with skipping way too many steps, because then you're not showing your work. Because it's possible that you can see what's going to happen, but you can't jump to that step unless you've justified it, so be careful with that. All right, we good? Any questions at all where anything came from? I know you'll have questions, but you're not going to speak to me, so I can't help you, because I've had questions all day, but okay. All right, so now let's look at number 9. This is factored, and the situation that is factored there is called what? Somebody say it. Say it loud. What does that look like? We talked about it on the front. Difference of squares, thank you. So this right here is the same as a plus 1 times a minus 1, which very easily is a squared minus 1, right? Like we've been factoring forever, that should be a no-brainer. So just because I know that doesn't mean I necessarily want to multiply it, but by looking at it, I don't think by leaving it factored, I could do anything with it. So I think I'm going to go ahead and multiply. So this right here just becomes cosecant squared x minus 1 over cosecant squared x. So let's talk about a couple different things we could do here. I've got quadratics, or I've got the squared, so if I see that cosecant squared, I could look over here, and cosecant squared minus 1 would give me cotangent squared. I could substitute in cotangent squared. Absolutely nothing wrong with that. If I then did that, then I'd have to get the quotients and the reciprocals and have a fraction and a fraction. But nothing wrong with it. It's not that crazy. Should be able to handle it just fine. But another option is that I have this fraction with two terms in the numerator, so I could split the fraction. And splitting the fraction is actually easier, but remember, whatever's easier is whatever you see first and what makes the most sense to you. If the first thing you see is to substitute in a cotangent and that's what you do, there's nothing wrong with it, okay? But I'm going to split this, and sometimes splitting it might not help, but if I split this, I see that I have some things in common, I think it would help me. So this is going to give me cosecant squared x over cosecant squared x minus 1 over cosecant squared x. So now this cancels out, and that first term is 1 minus, and then 1 over cosecant squared is sine squared. And by now, you might not even have to look at your chart. 1 minus sine squared should give you cosine squared. What questions do you have? Okay. So let's look at number 10. And so I've said before, if you have at least one term that's a fraction, most of the time what you want to do is go ahead and combine it into one fraction. But I said most of the time, because although I could do that here and there would be nothing wrong with it, I'd end up within the numerator tangent I'd end up with a tangent in the numerator somewhere. So eventually tangent would probably have to become sine over cosine, so I'd have a fraction and a fraction. I can actually avoid that if I do something before I combine them. Now, if you're working through a problem like this and you don't notice to do that, it's not the end of the world. And as long as you keep up with your work and you can read your own handwriting and you're not making stuff up, it's going to be fine. But I can take this tangent and go ahead and make it into a sine cosine thing. So I change this first term into sine theta over cosine theta, which might look like it's making things worse, but it's really not. Plus cosine theta over 1 plus sine theta. I know that going through these, you're not always going to make these exact same decisions I do. Honestly, I print out my notes from the year prior every time, and sometimes they're completely different. But so that when I'm working things, sometimes I glance down and I'm like, oh, no, that's not. So I know that, oh, I wasn't supposed to get that answer. What did I do wrong? But as I'm glancing down today as I'm doing this, I'm working some of these completely differently than from what I did last year. I think I've even worked some of these different in different class periods just because it, I don't know, seems to make more sense for y'all at that point. So there's different ways. I'm just trying to show you kind of a myriad of the different ones. So once I have this, now I have two fractions, and I need to combine them. I need a common denominator. My common denominator is going to be cosine theta times 1 plus sine theta. So just like anything else, that first fraction is going to have to be multiplied by something, and that something is the 1 plus sine theta. So I'll have to get sine theta times 1 plus sine theta. And then this one has to be multiplied by cosine over cosine, so that would be plus cosine squared theta. Now, my rule of thumb for distributing, because I always kind of want to get everything distributed, but I'm not going to distribute anything until I know I need to distribute it to be able to do something. Otherwise, I don't have to, first of all, and second of all, it might be better if I don't. So by looking at this, I need to simplify the numerator, and clearly in the numerator there is nothing I can do unless I actually distribute. And so I'm only going to work with the numerator and leave my denominator as it is, because you only want to change one thing at a time. So when I distribute in the numerator, I'm going to get sine theta plus sine squared theta plus cosine squared theta all over cosine theta times 1 plus sine theta. Everybody okay with where everything came from? Yeah. All right, and it's good if you can see how, like, where things are going, and because then that helps you with your next steps. But remember, be careful not to skip way too many steps. So I've got some Pythagorean stuff. So if I look at my chart, lo and behold, I actually have a sine squared plus cosine squared. These two terms, when I add them together, I get 1. That's what my reference chart says. So that whole thing can be substituted for 1. So this gives me sine theta plus 1 over cosine theta times 1 plus sine theta. Now, had I distributed the denominator just because I could, I may not see what I can do right here. So you don't do stuff just because you can. You kind of do as minimal stuff, just to make sure that you're rearranging a little bit at a time. Is what's in the numerator the same as what's in these parentheses? It absolutely is. It's backwards, but it doesn't matter for addition. If it was subtraction, I'd have to do another step. But this just cancels out with this, leaves me with 1 over cosine, which is secant theta. Make sure you're not leaving your thetas and u's and x's off as you write. You can't get sloppy with that work, or you're just going to get nailed with it's wrong, it's wrong, it's wrong. Your work doesn't make any sense. Okay? What questions do you have? We good? All right, let's look at number 11. So I want to look at it, algebraically first. I see lots of squares. I could substitute right now with Pythagorean stuff. Wouldn't be wrong, but may not be the best thing to do at this point. I have two terms. They have something in common. Therefore, I have a GCF. So I think factoring it out might help me a little bit. If I factor out that GCF, that gives me tangent squared y times 1 minus sine squared y. So remember, one thing at a time. If I don't know what to do with 1 minus sine squared yet, I hadn't been paying attention at all. So I get tangent squared y times, this gives me cosine squared y. Now, I could substitute something Pythagorean-y for tangent squared, but I don't know if that's going to help me. Like, that would give me two terms again. I think this is better this way. Instead, I can change tangent into a sine over cosine thing. So this can be sine squared y over cosine squared y times cosine squared y. Then these will just cancel out, and I'm left with sine squared y. What questions do you have? Okay. Let's look at number 12. Now we got cubes in here. Doesn't mean that it's any more difficult. But if I look at my numerator, do I have a GCF in the numerator? Yes, I do. So I think I'm going to factor that out. So I'm going to factor out that sine cubed. So I'm going to get sine cubed x times cosine squared, cosecant. Hang on, I'm saying the wrong thing. Cosecant squared x, once this catches up with me, minus 1, all over cosine cubed x. Okay. Everybody okay with that? Much like one of the ones on the front, I know that sine over cosine is tangent. So if I can, I can basically, it's kind of factoring out, but not really. I can rewrite this thing where I get sine cubed x over cosine cubed x times cosecant squared x minus 1. That's the same thing. So if you don't have some basic fraction skills, things like that are going to confuse you because you're not going to know when you're allowed to do what, but that's like way old business. So I can change, well, I don't even know that I want to change this to tangent yet, but I at least have a fraction like this, but I guess we go ahead and do that. So we'll do tangent cubed x times cosecant squared x minus 1. So this looks Pythagorean now that I've taken care of my cubic stuff. So I'm going to go and I'm going to look at my reference chart. And if I have cosecant squared minus 1, then that's going to give me cotangent squared. So I have tangent cubed x times cotangent squared x. If you understand the reciprocals well enough here, you may be able to jump to the last step, but again, there's nothing that says you have to jump. It might be a little bit better to do another step here. So if I do tangent cubed x, the reciprocal of cotangent, like I could make cotangent into cosine over sine. I can totally do that, but cotangent's also just the reciprocal of tangent. So I could just multiply this by 1 over tangent squared x. Right? I don't have to make it into a quotient. I can make it into a reciprocal. So now I can cancel this out with 2 of those, and I'm just left with the tangent of x. What questions do you have? I know that was a lot. We didn't even get to the hexagon. That's fine. We'll talk about that tomorrow, or I may even put it off another day, depending. I think tomorrow's is kind of long too. But I wanted to make sure I got through all of those different things. Right? Are there